Hi friends, welcome to our channel. In this video, I am solving KCET 2021 physics question paper. Let's start the video. First question is, the source of electromagnetic wave can be a charge. Options are option A, moving with a constant velocity, option B, moving in a circular orbit, option C, at rest, option D, moving parallel to magnetic field. So we know that when charges moving in a circular orbit, it undergoes centripetal acceleration, hence electromagnetic waves are produced. That means the source of electromagnetic wave can be charged if and only if the source will be moving in a circular orbit. Therefore, option B is correct. Second question is, in refraction, light waves are bent on passing from one medium to second medium. Because in the second medium, options are option A, frequency is different, option B, speed is different, option C, coefficient of elasticity is different, and option D, amplitude is smaller. This is direct question. We know that refraction takes place because of change in speed of light when it moves from one medium to another medium. That's all. So option B is correct. Third question is, if the refractive index from air to glass is 3/2 and that from air to water is 4/3, then the ratio of focal length of the glass lens in water and in air is. Options are option A 1:2, option B 2:1, option C 1:4 and option D 4:1. Given that refractive index from air to glass is 3/2 and from air to water is 4/3. Now from lens maker's formula, when glass lens is in air, formula will be 1/FA equals Ng/1 minus 1 into 1/R1 minus 1/R2, which implies 1/R1 minus 1/R2 equals 1/FA into Ng minus 1. Take it as equation 1. Similarly, when glass lens is in water, formula will be 1/FW equals Ng/Nw minus 1 into 1/R1 minus 1/R2, which implies 1/R1 minus 1/R2 equals 1/FW into Ng/Nw minus 1. Take it as equation 2. So from equation 1 and equation 2, we can write 1/FA into Ng minus 1 equals 1/FW into Ng/Nw minus 1. Therefore, FW/FA equals Ng minus 1 by Ng/Nw minus 1. Now substitute values of Ng and Nw. Therefore, FW/FA equals 3/2 minus 1 by 3/2 by 4/3 minus 1, which equals 1/2 by 1/8, which equals 4/1. Therefore, ratio of focal length, that is FW is to FA equals 4:1. So option D is correct. Fourth question is, two thin biconvex lenses have focal lengths f1 and f2. A third thin biconcave lens has focal length of f3. If the two biconvex lenses are in contact, the total power of the lenses is P1. If the first convex lens is in contact with the third lens, the total power is P2. If the second lens is in contact with the third lens, the total power is P3. Then, so here we need to find the values of P1, P2 and P3. That's all. They given that focal lengths of the biconvex lenses are f1 and f2 and that of the biconcave lens is f3. So we know that for a biconcave lens, focal length is negative, and for biconvex lens, focal length is positive. That is, f1 equals plus f1, f2 equals plus f2 and f3 is minus f3. We know that total power of the lenses is Fp equals 1 by F1 plus 1 by F2. This is formula. Therefore, from data, P1 equals 1 by F1 plus 1 by F2, which implies P1 equals F1 plus F2 by F1 F2. Similarly, P2 equals 1 by F1 minus 1 by F3, because here one convex lens is in contact with third concave lens. Therefore, P2 equals F3 minus F1 by F1 F3. And finally, P3 equals 1 by F2 minus 1 by F3. Here also, second biconvex lens is in contact with third biconcave lens. Therefore, P3 equals F3 minus F2 by F2 F3. So, option D is correct. Fifth question is, the size of the image of an object which is at infinity as formed by a convex lens of focal length 30 cm is 2 cm. If a concave lens is of focal length 20 cm is placed between the convex lens and the image at a distance of 26 cm from the lens, the new size of the image is. Options are: option A is 1.25 cm, option B is 2.5 cm, option C is 1.05 cm, and option D is 2 cm. Now let's draw the diagram for given situation, which looks like this. From this diagram, the object distance from the concave lens is 4 cm, that is U equals 4 cm, and we know that for concave lens focal length is negative. Therefore, focal length of the given concave lens is f equals minus 20 cm. For concave lens, 1 by f equals 1 by v minus 1 by u. Therefore, 1 by v equals 1 by f plus 1 by u, which equals 1 by minus 20 plus 1 by 4, which equals 4 by 20, that is 1 by 5. Therefore, v equals 5 cm. Now, initially image formed by convex lenses acts as virtual object for concave lens. Then size of an object for concave lens will be h0 equals 2 cm. So we know that magnification equals hi by h0, which equals v by u. Therefore, size of the image is hi equals v into ho by u, which equals 5 into 2 by 4, which equals 2.5 cm. Therefore, new size of the image is 2.5 cm. Option B is correct. Sixth question is, a slit of width A is illuminated by red light of wavelength 6500 angstrom. If the first diffraction minimum falls at 30 degree, then the value of A is. We know that for diffraction minima, n lambda equals A sin theta. For first diffraction minimum, n equals 1. Therefore, A equals lambda by sin theta. Now given that lambda equals 6500 angstrom and theta equals 30 degree. Therefore, A equals lambda by sin theta, which equals 6500 into 10 power minus 10 by sin 30 degree, which equals 65 into 10 power minus 8 by 1 by 2 equals 130 into 10 power minus 8 meter equals 1.3 into 10 power minus 6 meter, which equals 1.3 micron. So, option B is correct. Seventh question is, which of the statements are correct with reference to single slit diffraction pattern? First statement is, fringes are of unequal width. Second statement is, fringes are of equal width. Third statement is, light energy is conserved. And fourth question is, intensities of all bright fringes are equal. We know that in single slit diffraction pattern, fringes are of unequal width and light energy is conserved. So, first and third statement is correct. Therefore, option A is correct. Eighth question is, in the Young's double slit experiment, a monochromatic source of wavelength lambda is used. The intensity of light passing through each slit is I0. the intensity of light reaching the screen SC at a point P, a distance x from O is given by. Here small d is much lesser than big D. Now we know that for double slit experiment, phase difference phi equals 2 pi by lambda into delta x. Path difference delta x equals n lambda, which equals d sin theta. So we know the formula for intensity of light is I equals 4I naught into cos square phi by 2. We also know that in Young's double slit experiment, n lambda is equals to xt by d. Therefore delta x equals n lambda equals d sin theta, which equals xt by d. Therefore phi equals 2 pi by lambda into delta x, that is xt by d, which equals 2 pi d by lambda d into x. Therefore intensity of light, that is I equals 4I naught into cos square of phi, that is 2 pi d by lambda d into x by 2, which equals 4I naught into cos square of pi d by lambda d into x. So option B is correct. Ninth question is, the work function of a metal is 1 electric volt. Light of wavelength 3000 angstrom is incident on this metal surface. The velocity of emitted photoelectrons will be. Now given that work function W equals 1 electron volt and wavelength of the light lambda equals 3000 angstrom, we know that maximum kinetic energy of photoelectrons is Ek equals E photon minus work function W electron volts, that is half mv square equals hc by lambda minus W electron volts. Here hc equals 6.625 into 10 power minus 34 into 3 into 10 power 8, which equals 19.87 into 10 power minus 26 by 1.602 into 10 power minus 19 electron volts, which equals 12.35 into 10 power minus 7 electron volts. Take approximate value, that is 12 into 10 power minus 7 electron volts. Therefore half mv square equals 12 into 10 power minus 7 divided by wavelength, that is 3 into 10 power minus 7 minus 1 electron volts, which equals 3 electron volts approximately. Therefore V square equals 6 electron volt by m, which equals 6 into 1.6 into 10 power minus 19 by 9.1 into 10 power minus 31, which is approximately equal to 10 power 12. Therefore V is approximately equals 10 power 6 meter per second. So option D is correct. 10th question is, a proton moving with a momentum p1 has a kinetic energy 1 by 8 of its rest mass energy. Another light proton having energy equal to the kinetic energy of the proton possesses a momentum p2. Then the ratio of p1 minus p2 by p1 is equal to. So option A is 1, option B is 1 by 4, option C is 1 by 2 and option D is 3 by 4. Here they given that momentum of proton is p1. So we know that the rest mass energy of proton is E equals mc square. So by the given data, kinetic energy of the proton will be Ke equals 1 by 8 into mc square. Now we know that momentum P equals square root of 2m into kinetic energy. Therefore from the given data, P1 equals square root of 2m into 1 by 8 into mc square, which equals mc by 2. Now they also given that for proton of momentum P2, E proton equals kinetic energy of proton, which implies hc by lambda equals 1 by 8 into mc square. Therefore momentum P2 equals h by lambda, which equals mc by 8. Therefore P1 minus P2 by P1 equals mc by 2 minus mc by 8 whole divided by mc by 2, which equals 3 by 8 by 1 by 2, which equals 3 by 4. So option D is correct. If you like this video, then press the like button. If you got any benefit from this video, then share this video with your friends also. If you have any query regarding problem solving, then comment on the video. If you want more videos like this, then please subscribe to our channel. Thank you for watching.